Okay, so 13.2, you guys can go ahead and print out this whole template, or you can just write this on regular line paper. So if you don't have a printer, I'm sorry, you're going to have to write this out, okay? The homework, by the way, is on the top right, and it has this and it has this. So technically, we did this already. So technically, this is your homework for Thursday and this is your homework for Monday, but I would highly advise you to do them early just because you do have a mini quiz on Monday, okay? So back to here. So algebra techniques for finding limits. So we've actually kind of talked about a lot of this already, and then there's one new part that we'll get to. So limits involving piecewise defined functions. All right, so this says for a limit to exist, the left limit and the right limit have to be equal. That's what that really says. For there to be a limit, the left side and the right side have to go to the same place, which we've talked about. And then can you write this in, please? So the left side and the right side have to approach the same number. So something like that, okay? And then I show you that right here. So even if you don't draw the piecewise function, you should be able to get the answer by finding the left limit and the right limit. So as x goes to 3, the limit of f of x is the left side, I would plug the 3 into here. And then for the right limit, I would plug the 3 into here, right? This is to the right of 3, this is to the left of 3. So then you plug it in, you get your left limit, you get your right limit, you write it really neatly. You don't just write this, okay? So you write it neatly, and then you get 18 both times. So because that's the same number on the left and right limit, then the limit for the whole thing is going to be 18. So you guys are going to try example 2, and then you're going to pause the video, then you're going to start it again, and then hopefully you got that for example 2. Okay, so you can see that's why it doesn't exist. The left and the right, they go to different places. Okay, so steps to evaluating limits algebraically. So we talked about a lot of these before, so especially number 1, number 2, number 4. I'm just adding a number 3 in there, okay? So you can do 1, 2, 3, 4, it doesn't matter. But number 1, you always try to plug it in. So that's what you do first, and if it works, great. I said only works if you're plugging into an equation with no holes or asymptotes. You don't have to really worry about that. Just try to plug it in. If it doesn't work, then you go on to step 2. You're going to simplify. You're going to factor, simplify, whatever, and then you're going to plug it in. And if that works, great. But if it doesn't work, you're going to go on to number 3. We're going to talk about special rules in a second. And then if you can't remember the special rules and you have a calculator, then you can always use your calculator to make a table. Okay? So you guys are going to do step 1. If that doesn't work, step 2. And then if that doesn't work, then I'll show you the special rules. The special rule only applies technically to number 12. So you're going to try number 3 all the way to number 11 on your own. You're going to pause the video, and then you're going to check your answers, and you're not just going to copy me. So here are answers to 3 through 10. So you can see for the first ones, you just plug it in, you get an answer. And then for number 9, you plug it in, you get 0 over 0. That's no good. So you have to factor, and then you plug it in. And then this one also, you have to factor, and then you plug it in. So you always try to plug it in first. Okay, number 11, you plug it in, you get 0 over 0. That's no good. But then I give you a hint. You can factor using grouping. So then you factor, and then you plug it in. Okay, for number 12, we're going to move on to the back first, and we're going to talk about those special rules, and then we're going to come back to number 12, okay? So number 12, right in the back on the bottom, it has special rules to memorize. So these, it would be really, really helpful if you memorize them, and then I added on a number 6 as well, by the way. If you don't memorize it, then if you have a calculator, you can put it into your calculator each time, but that will take time. So I want to show you why these are true, okay? So, so the first thing you're supposed to do is plug it in. But if I plug it in, what is the sign of 0? The sign of 0 is 0. 0 over 0 is not an answer. So this and this, if you flip it upside down, they will give you the same answer, and it's 1. So that seems super weird, but I'm going to show you why that's true and how you can check it every time. So in my graphing calculator, so So I'm going to pretend that's my graphing calculator. And then I already put it in there. So here is my, my function, y equals. And then if I graph it, just if I graph it, I can see that it crosses, it looks like it crosses the 1. It doesn't really. Like if I zoom in far enough, if I zoom in, then I can almost see a little gap. I can like almost see the little gap, but it's really hard to tell. But if I look at the table, I can see at 0 there's an error. So if yours doesn't look like this, then it's because you need to set the table. So I want to start it at 0 because that's what I care about. And then I'm going to do the change as 0.01. I'm going to go back to the table and scroll up a little bit. And you can see that as I'm getting closer to 0 this way, these numbers very slowly get bigger and they get closer to 1. As I go closer to 0 this way, these numbers are getting slightly bigger and bigger and they get closer to 1. So this number and this number are both super close to 1. That's why my answer is 1. So the sine and tangent special rules are the same, so that's why I can see. You can see it in the graph, and then also I like to just list those one after the other. This one is different. 1 minus cosine x or cosine x minus 1. Those are going to give you 0. So if you put it into your graphing calculator, you'll see why that's true. And if you plug in cosine of 0, it's 1. 1 minus 1 is 0 over 0. That's no good. But then if you plug it into a calculator, you get this. So it's easier if you just remember, okay? And then another way you can think about it is you take the coefficient over the coefficient. The coefficient over the coefficient is 1. The coefficient over the coefficient is a over b. Same thing here, a over b. Same thing here, a over b. So how does this work right here? This is basically the same as this. If I were to multiply, so let's say I were to multiply, so sine of x, if I did sine of x over x times x over, well, I don't want to say it that way. Well, for now, I'll just leave it like that, and then we can talk about it in the notes, or together tomorrow, okay? These we already know. So these, like, it's not to memorize. You're supposed to know, like, what is the sine of 0? 0. What is the cosine of 0? 1. What is the tangent of 0? 0. So these are not memorizing. These you already know, okay? Okay, so using these facts, can you try to do number 1, or sorry, on the next page on the right side, can you try to do A all the way through? I mean, I feel like you could do A all the way through G, but give it a try. And then pause, and then unpause. And then you're going to check your answers for A through G. So here's A through G. So I think the first ones are pretty evident. And then I added in a J. So can you add that in? So this one is just x over cosine of x. So you can see this is the same as this, except it gets flipped, right? So 1 over 0 doesn't exist. 0 over 0 would be a special rule, but 1 over 0 does not exist. And then 0 over 1, 0 divided by 1 is 0. Okay, this one is a little bit interesting. This one, you split up into 2 of them, and then you can use the special, and then you can use the special rule here, and then you can use the special rule here. So this gives you a fourth, this gives you a fourth, and then that's how you get 1/16. You do the same kind of thing for H. Give it a try before I show you. And then for H, you're going to be super careful, because when it says 7x to the 5th, it's not 7, 7, 7, 7, 7. It's 7 with 5 x's. So then you get this at the end, because then you do 3 over 7 times 3, 3, 3, 3. And then for I, you're going to do it step by step. And be really careful. Give it a try. And then if you get stuck, here you go. So I split this up into that. and then I can take this as a special rule and then this all by itself next to it. The special rule tells me that that's 1, and then I just plug the 0 into here to get 3. 1 times 3 is 3. So there you go. Okay, now you're going to flip the paper and do that last problem on the front. Give it a try. I gave you a little hint for it. And then you're going to check. And then final answer. Right? So if you split it up into 2 fractions, then you can just divide and then special rule, final answer. Okay, the very last part is the average rate of change. Okay, so in calculus and in, all of math, the average rate of change means slope. So we're finding a slope, and then this says find the limit of the slope, basically. So if we want to find the limit as x approaches 2 of this, then it's really a slope. And this is just the slope formula, right? Like change in y over change in x. So this is the y values, this is the x values. So if we're finding the limit as x approaches 2 of the slope, then it's going to be f of x minus f of 2, because we're going towards from x to 2. So just think of it that way. See, x2, x2, x2. So y's over x's. And then what is f of x? F of x is that function. So I just plug in that function. What is f of 2? I plug 2 into the function, I get 10. On the bottom, I stick with x minus 2. And what will happen every single time without a doubt, unless you make a calculation error, is when you subtract that, you'll be able to factor and you'll be able to cross out the top and bottom. So you'll definitely be factorable on top so that you can cross out the whole, and then you get this left over. And notice how I wrote limit every single time. So technically you're supposed to write limit until you plug in the number, and then you don't have to write limit anymore. So final answer. So my slope at 2 for this is 7. So this is a parabola, and at 2, my slope is very, very big. So at 0, my slope would be 0, right? So think about that parabola and think about that roller coaster. Your slope would be 0 at 0, but at 2, it would be a lot higher. So see, at 2, it would be 7. Okay, so there's your notes. And then again, your homework is at the very top, and we already did this. So your homework is really that part, okay? Give it a try, and then I will see you in class.